Okay, so it's Dr. Eng here. So for this video, we are going to be working on this static equilibrium problem. So the first part of the question is to work out the sum of the forces in the x direction, so f of x. The second part will be to work out the sum of the forces, sum of the force components in the y direction, f of y. And finally, we will also be working out the moments about point A, which can be seen here. The first step on how to solve these problems would be to draw a free body diagram, which I'm going to do now. So we can understand the forces acting upon this structure or beam. So the first step would be to remove the supports. We know from our previous video that this is a fixed support, and the second support here, it's a roller support. Both of these supports will need to be removed and their applicable forces would need to be added. So we know by removing the roller support, there'll be a force here, which I'm going to call YA. And by removing the fixed support, there's going to be a force here called YB. There will also be a horizontal force, which would be 0, which I would call, change the color, XB. That force is obviously 0. Then I'll proceed by adding the forces. So got a force acting on the end of 80 kilonewtons. And then we've got a length of 1.2. And then we've got another length of 0.4. And then we've got a force then which we would need to resolve. I've gone through resolving forces in my previous video. So if you're still unsure, please do take a look through my previous video. So in this case, it would be 120 sine 60. So the force going down would be 120 sine 60. And you would also have a force obviously going through the beam, which in this case would be 120. Well, I'll do that in a different color so it's visible. So that'd be 120 cos 60. So next, we've then got another distance, which in this case would be 1.5. And then from that point there, we've got a force acting on the end, which is obviously 100 kilonewtons. When solving a static equilibrium problem, it's very important to understand what forces are acting upon the structure. And in order for us to simplify the problem, it's best to start with this by creating a free body diagram first before attempting to complete the question. So now, as we know what forces are acting upon the structure and we've resolved that force, we can now start working out the sum of the force in the x direction, so the f of x component. So we know by looking at the free body diagram that the sum of the forces in the x direction equals So let's look in the X direction. We've got XB going through the structure. That force is obviously created when we remove the support. And then in the opposite direction, we've then got 120 cos 60. That's obviously from when we resolved that force which was acting on the structure. Okay, so next we can work out the sum of the force components in the y direction. So sum of the force components in the y direction. So if we have a look, you've got YA plus YB, which where the force is acting upward, YA plus YB. Next, we've got the forces acting down, so minus 100, minus 80, and then we've also got that force that we resolved again, 120 sine 60. We then can proceed by working out the relevant equation for the moment. So the moment would be, so when we remove the support, the point A would be about there. Point A. So next we can work out the sum of the moment at point A. So yeah, we can get the relevant equation. So we can do 80. So we know to work out a moment, it's force times perpendicular distance. So in this case, it would be 80 multiplied by the 3 points. And then we would do plus 120 sine 60 multiplied by 2.1. So we add those distances together. And then we've got minus 100 times 1.5. And then we've got the support as well. So minus YB times 2.5. So we know that for compatibility or for equilibrium, whatever you want to call it, for equilibrium, sum of the forces in the x direction equals sum of the forces in the y direction equals sum of the moments in the a direction, which equals 0. Then I would want then you would do the basic manipulation and you would be able to solve for sum of sum of x, sum of y, and the moment for each of these individual components. So we know that you should then end up with an answer once you've solved for these equations. So xb would be 0, YB would be 4 kilonewtons, and YA would be 16 kilonewtons. So those would be the answer for this particular question. So I do hope that you did find my video useful. Please do like, share, and subscribe, and I'll see you for the next one.